Hello everyone, let's take a look at our next problem. So this problem comes from a viewer and it says, let omega be a root of x to the power of 19 equals 1, but omega is not equal to 1. Calculate omega plus omega squared plus omega to the 4 plus omega to the 8 and so on up to the power of omega to the power of 2 to the power of 17. Okay. So my first thought immediately, if omega is a root, if it's a root of x to the 19 equal 1, but it's not equal to 1, then it's got to be complex, right? It's got to be a root of unity. And there are 18 complex roots to that. And then we're given a massive expression where we're taking these exponents. The exponents are all powers of 2. So omega to the power of 1 plus omega to the power of 2 plus omega to the power of 4 and so on. Okay, so I'm starting to see what this is. All of these things, omega to the power of 19 is equal to 1. Omega clearly has a modulus of 1, and we can figure out what its argument is. Anytime you raise omega to some power, you're just rotating it around the unit circle. The complication is going to be in adding these things together. So I should be able to figure out how many terms are there here in total. There are 18 terms here in total. And there might be some element of group theory going on here, right? The roots, the 19th roots of unity are going to form, are they going to form a group? Like, I think, let me write down what's going on here, okay? So we're given omega to the 19 is equal to 1, but omega is not equal to 1. And we're asked to compute omega plus omega squared plus omega to the 4 plus omega to the 8 all the way up to omega to the power of 2 to the 17. So there are 18 terms here in total. And so it's been a long time since I've done algebra, but my first instinct here is that all of these numbers are themselves, they are certainly themselves also going to be 19th roots of unity. They're probably just going to be permutations. It's like each of these is going to be, when you raise these to these exponents, they're just going to permute them around, right? Is that correct? I'm gonna have to. I might just have to play a little bit with like a geometric picture to convince myself whether that statement is true or false, that each of these is itself a different 19th root. Okay, so I think I have the answer here. Like I said, it's been a long time since I've studied algebra or group theory. Some of this could probably be understood by some elementary number theory stuff too, which again, it's been a long time for me. But what I said, I'm fairly confident in what I'd said, that each individual term in this sum is itself a different root of this equation, and they're never equal to 1. So basically, whichever of the 18 roots we pick out here, when we raise them to all of these exponents, we basically get some ordering of all of the 18 of those complex roots without repeating any of them. And so then if you think about what all the roots look like distributed around the circle, well, if you include all 19 roots, they're symmetric around the origin on the unit circle, and they will add up to 0. So if you take the 18 complex ones, so the only one you're missing is 1, then the other 18 complex roots have to add up to -1. So I'm pretty sure this is what the answer is. I would need to confirm a couple of my individual steps, either by actually computing things or convincing myself that some of the group theory stuff that I do remember is correct. But I'm pretty sure this is correct. Check the description below to see if I have any additional thoughts or if I catch an error somewhere. If I'm wrong, you can yell at me in the comments. Otherwise, thanks for watching.